All right, students, so yesterday we were doing simplifying radicals. Today we're going to be doing dividing radicals. All right, now we call this rationalizing the denominator. It might seem a little funky at first, but again, we're going to be using radicals a lot with Pythagorean theorem. We're just setting the foundations, building our skills, and we're going to progress from there. Before we do dividing radicals, we're going to do some pre-work. Let's make up some examples of multiplying the same radical real quick, and then we'll draw a conclusion on a pattern. All right, so I want you guys to think of a number. 3. All right, I read some of your guys' brains. You guys were thinking of 3. The square root of 3 times the square root of 3 is equal to 3. I was able to do that in my head. Why? The square root of 3 times the square root of 3 is just the square root of 3 square. And in the last video, I said these are inverse operations. They undo each other. All right, squares and square roots. Inverse operations, they undo each other. So you're just left with 3. All right, I want you to think of another number. 17. I've read some of you guys' brain. You guys were thinking 17. Square root of 17 times the square root of 17 is just 17. All right, this pattern is true for any number you can think of. The square root of 321 times the square root of 321 is just 321. Because you get square root of 321 squared, the square root and square undo each other, you're just left with 321. All right, so that's just some pre-work. The conclusion I guess we can make, we'll be very generic about it. A is just some real number. The square root of A times the square root of A is just A for any real number. All right, so let's read this. Dividing radicals, aka rationalizing the denominator. You cannot leave a radical in the denominator. You must simplify the fraction and or rationalize the denominator so that the radical is no longer in the denominator. Simplify the numbers in front of the radical and simplify the numbers under the radical. Easy enough, right? Well, not really. It's a little confusing. It's a little awkward at first, but this is it. Let's work through an example. It's not too scary. You're just gonna pick the radical and denominator and multiply. We'll keep it unmathematical. Some people would get mad if I wrote this. Multiply top and bottom. I should say numerator and denominator. I didn't feel like writing those big old words. All right, so this is it. See the square root of 5? We don't like this in the denominator for several reasons. One, if you just get it out of there, the numbers are considered more simplified, nicer, cleaner, and you're going to see some unrecognizable numbers become very recognizable once you rationalize it. So I'm going to pick the square root of 5, and I'm going to multiply by radical 5 over radical 5. I'm multiplying the top and bottom by radical 5. Now really fast, what's radical 5 divided by radical 5? It's just 1. All right, 5 divided by 5 is 1, 17 divided by 17 is 1, 92 divided by 92 is 1. So since I'm multiplying the top and bottom by the same number, I'm only multiplying by 1, so I'm not changing the value of anything. Now this is it. This is the punchline. You're just going to multiply straight across. You're going to get 6 radical 5, because numbers under the radical and numbers that don't have a radical can't be combined, and then it's just 5. And this is your answer. This is considered simplified. Now again, it seems awkward at first, but as you progress and do this more often, you're going to actually prefer numbers that don't have radicals in the denominator. All right, looking at this example over here, we're going to pick the radical in the denominator, which is radical 3. All right, I'm going to pick this number, and I'm going to multiply the top and bottom by it. Now realize this number, radical 3 over radical 3, is just 1. So I'm multiplying by 4. I'm multiplying 4 radical 3 by 1. So I'm not changing the value of it. Then you just multiply straight across. All right. You're going to do 4 times radical 3, which is 4 radical 3. You're going to do radical 3 times radical 3, which is 3. And boom, that's your answer. This is considered simplified. All right, so it seems scary at first. Still might be a little bit scary, but again, same thing, as we progress and build these skills, we're gonna get really good at it. All right, so looking at this one right here, the square root of 6. This one's actually a little bit of a lengthy one, but even though it's a little bit more lengthy, you're gonna see why it's good to rationalize the denominator. I'm gonna get 2 radical. I gotta multiply the numbers under the radical together. I'm gonna get 18 over 6. Now all kind of bizarre things are gonna happen here. Like I'm gonna simplify 2 over 6. That's 1/3. Radical 18. Well, I'm gonna simplify radical 18. That's radical 9, radical 2, which becomes 3 radical 2. All right, and I had this 1/3. So I get 1 times 3 is 3, divided by 3. That all just simplifies, and my final answer is radical 2. All right, this is complex stuff at first, but we're progressing through it, building our skills. This is a great example of why of rationalizing the denominator is good. I had 2 radical 3 over radical 6. That's bizarre. I have no idea what that number is. I see radical 2. I know that's about 1.4. All right, let's cruise right along. Let's just finish all these, and then we got. We'll do 3 videos again, probably. All right, so radical 5. Build our skills. Slowly build our skills. I'm going to pick radical 5 and multiply top and bottom by radical 5. And I'm going to get 2 times radical 15. Remember, I get 3 times 5, which is 15. And then radical 5 times radical 5 is just 5. All right, now radical 15 cannot be simplified. This is my final answer. Goofy at first, we'll progress, we'll get really, really stinking freaking good at this stuff. All right. Another reason why rationalizing the denominator is good. Radical 18 over 3 radical 2. What the heck is going on here? I don't know. All right. There's a bunch of ways to do it, but I'm just going to use brute force. I'm going to do the same method every single time. I'm just going to get really good at this one method. All right. So on this top, I'm going to get radical 18 times radical 2, which becomes radical 36. And this denominator, I'm going to have 3. And then radical 2 times radical 2 is just regular 2. So now I have square root of 36 over 3 times 2. Well, what's the square root of 36? 6. What's 3 times 2? 6. So I have 6 over 6, which is just 1. So this is probably my favorite example of why rationalizing the denominator is so important. We had some crazy number, simplified it, realized it was just 1 all along. Building our number sense right now. And last problem. Again, a bunch of ways to do this. I'm going to use the brute force method, just do the same thing. Pick the square root of 24, multiply both top and bottom by it. I'm going to get the square root of 288 over 24. All right, now like we can dissect this. Let's just focus on the square root of 288. All right, what's the largest square factor? Again, you might have to guess and check. It might take a while, but eventually you'll come to the conclusion that's square root of 144 times the square root of 2, which is 12 radical 2. And I'm going to take this 24 here, that's still in the denominator, and then I'm just going to simplify, get 12 over 24. So I can write it as 1/2 radical 2, but I prefer radical 2 over 2. All right, that's probably the best way. Okay, cool. All right, that's it for video 1. We're going to practice our skills some more in videos 2 and 3.